First off, I want to thank everybody for coming. My name is Mike Cappuccio. I'm the owner of the company. I've been in business now. This is my 30th year of owning N.E.T.R. We are a full source air conditioning and heating company. We adopted the ductless technology about 20 years ago through Mitsubishi Electric, and we've kind of moved forward with that. I've seen it, a revolution of what's actually happened with these products in the past 20 years, and we built this room last year to kind of share with homeowners now to, hey, how does this technology work? A lot of times we go out to homes and we're doing things, and it's I tell people don't buy anything until you can at least come see how things work and what we do and how we do it. Because a lot of times we get out into homes and we start taking these things out of boxes and people look at it and they're like, oh my God, I just saw this in a brochure, and geez, that's kind of big, or we always tell people, come here, touch, feel. So we have all in the back here. We have Paul on the left, Jimmy, Chip, Jason. These guys can all show you guys how these work, different models. We'll turn some stuff on. We'll give you some ideas of sound and things like that. So, but enough about that. I want to move on with the presentation so you guys have an idea of what's happening. I'm going to go through this kind of quick, okay? We're going to start with a little bit of the heating side of why you might want to use this, because a lot of people think of it as just an air conditioning system. It is a heating system too, and I want to talk about that and why you might want to consider this for heating as well as air conditioning. We do a lot of buildings, full source of heat. This is the only way we heat them. We don't heat with gas in some areas, so we're going to get into a little bit of the touch on the heating side. Then we're going to get into the cooling side, the different systems, how they work, the different controls that you can use with them, how you can integrate it with a boiler or an oil or electric system in your home today. And then we'll get into what's happening with Mass Save and the rebates and things like that, and what's going on with that. So I'll move forward. But why should you consider heat pump technology? Well, it's definitely a greener way to heat your home. A lot of people now. I'm here in Cambridge, Somerville. All these towns want to go to carbon neutral footprints by the year 2050. Now they're saying they don't want to have natural gas. They don't want to have oil. They don't want to have things burning. So and why do we look at that? We're creating electricity this way today. When we look at the way things are turning now, we've got solar farms everywhere, we've got wind farms everywhere, and they're trying to electrify the grid and get away from having to burn all these fuels. So when we look at the United States today in heat pump technology, it's way behind the world of what's going on. You go over to Asia, South America, places like that, everything is being heated and cooled by ductless mini splits. The United States is about 8% right now, and a lot of that 8% is in big buildings. A lot of commercial buildings now are being done with VRF products and Mitsubishi products and LG, all these different manufacturers now that are coming over from Japan and Korea. So you can see we're way behind the technology. We're still using oil, we're still using gas, we're still using electricity, electric baseboard heat, things like that. So you're going to see things are going to change very quickly in the next few years. So, how we use energy in our homes today, 45% of our energy is being dictated towards space heating, water heating, things like that. So, when we look at how we're using this, it's really a lot of our energy is being used for heating. When we look back at, how things used to work, this was how things were done years ago, 20 years ago. When I look back when I first got into doing this, it was a one-on-one system. There was one condenser outside like that right there and one indoor unit. That was really all they made. It was more used for, do I have a sunroom in addition, things like that. It was more of a spot cooling system. It wasn't really designed to do a whole home. But now when we're looking at how we're doing things, I'm going to say 95% of jobs we're doing now are all multi-zone jobs. What do I mean by that? We have multiple zones in your home. So when we look at these different areas of our homes, we have different zones. We break the home down into zones and temperature. So, people say, well, why would I want to use this versus central air conditioning? When we look at how we do our homes, we have lights in every room. We have water in different rooms. We have outlets in every room. We zone off those things. The biggest thing that we use to air condition our homes today is a big central air conditioning system, and we're air conditioning parts of our home that we're not even in half the time during the day. Example, you're not, some people sleep in their bedroom during the day, I get it, but most of the time it's being done at nighttime. So you're not in a bedroom during the daytime, and you're air conditioning this whole entire home in areas where you're not in. For the efficiency standpoints now, we can turn certain rooms off. Example, we can turn that room off. We can come in and zone out your home. That's how we pick up the efficiencies of what we do. When we look at how we use electric in our homes today, 50% of electricity is being used for HVAC, for heating and cooling needs, on the electricity side of what we're doing. It's a lot of electricity that we're using to do certain things. It's a big number, real big number of what we're using today. When we look at this, heat pumps are part of the solution to cure some of these problems. So, how does a heat pump work? Or how does a basic system work? Well, there's 4 things involved in it. When we look at this, the heart of the system is the compressor. The compressor is like the heart in your body. It's what's doing the pumping. It's pumping the blood. And then it's pumping refrigerant out into a coil to the condenser. That's the piece that goes outside. That is the condenser. That's what we call, has a coil in it, and refrigerant gets sent out of that compressor, goes into that coil, picks up the outdoor heat, goes through a valve on the inside unit, and then there's another heat transfer coil inside, which we call the evaporator coil. And then that refrigerant gas just comes back to the compressor right here, and that's it. But this coil right here is basically what sits inside the home. It's the wall unit, or the unit that sits in your central air conditioning unit. There's 2 coils. There's 2 coils in the system, one on the inside, one on the outside. This is where all the heat transfer is taking place. Just a real basic heating and air conditioning system of how it works. Now, when we look at a basic heating and air conditioning system today, this is how they work. They go on and off. They turn on and they turn off. They come on, they bring the temperature down to the set point right here. So your thermostat says, hey, I want 72 degrees in the room. It gets up to 73. It says, whoa, okay, come on. Compressor outside goes on, and it goes on, and it goes off, okay? And a lot of times with this, we have uncomfortable temperatures, because when we do a whole home with a thermostat, we have one thermostat, and it's usually in the hallway somewhere, or near a central return grill, and it's not in the separate rooms. It's in an area. So we end up with a lot of hot spots, cold spots. A lot of times we go into homes, we see where they've put a unit in the attic to do central air conditioning, and they've run ductwork down through closets. It gets done very often, and there's one unit in the attic, and ductwork comes down through closets. Well, the ductwork, first off, has to line up with wherever that closet is on the first floor is where that vent's going to be. And there's usually one thermostat. There is one thermostat only on that, and it would be in the downstairs. Cold air drops. You're going to have a very cold downstairs and a very warm upstairs if you go and do that. Happens a lot. We see it, and it goes on and off, on and off. And you see the lights dimming and when this happens. Our systems are a little bit different than this. These also run on AC voltage current, and they run on 60 hertz of electricity, which is the norm in the electric stratification of how we use our power in the United States. The ductless systems from overseas, okay, run a little bit differently, okay? First off, the compressors inside of them aren't AC voltage, they're DC voltage compressors, and they run off a PAM controller in there. Okay, so they're very efficient. They take the power and they convert it to a DC volt. And what happens is they run on 30 hertz. They don't run on 60 hertz. That's how we pick up the efficiency. All right, so our compressors, they're very much like a cruise control. Right here is where they're a very soft start compressor, and I'll show you this today, guys, of how a system starts up. It starts up on a very slow speed, and then it ramps up. And then as it ramps back down again, and it's doing this with the room temperature right here. So when the room temperature is very warm, the compressor runs very fast. When the room temperature gets to the temperature set point of 70 degrees, it says, okay, just slow down and run at like a very, very slow speed of cruise control. And you can see we knock out all the hertz on that, and that's how we pick up our efficiency. At 1 degree within temperature of where the thermostat is on that unit draws about what 8 light bulbs are when it's on the system with that type of compressor. So it's much more efficient than an AC volt compressor, how it works. So when we look at our heating seasons, You know, and we look at our cooling seasons. This is last year's heating and cooling season. And when we look at how many hours are in a year of a heating and cooling season, you know, when we look at our cooling season, I mean, we had 343 hours from 80 to 90 degrees. We had 37 hours from 90 to 99. So we have a lot of humidity. We don't have a lot of heat, okay? And when we look at, you know, the bulk of our heating season, look where it is here. You know, it's from like this 20 degrees to 49 degrees in the winter time. So, you know, we have some cold days, but I mean, look, we had 36 hours from 0 to 9 degrees, and we had 10 hours from -1 to 10. So from a heating perspective, we don't have a lot of extreme cold temperatures. So when we look at how fossil fuels and what they cost, okay, and how they operate, I mean, we operate in what's called COP, the coefficient of power, and the cost per million of BTUs. So when we look at electric resistance heat, you know, that for around $1 million at the rates that are, I think it's 20 cents a kilowatt, is about $52.74 to create a million BTUs on that. All right. When we look at oil is very expensive to heat with too. That's about $27. Propane, if anyone's using propane to heat with, very expensive to operate with. And then we operate in these different numbers right here. Okay. These COP of 2, 3, 3.5, and 4. This is our speed. When we slow down, we're about $13.18 to create a million BTUs. Gas, you can see, is very efficient. Gas is the most efficient way to heat your home today. It's pretty much right there with how we heat our homes. So if you've got gas in your home, this probably is not the way you'd want to heat your home with it full time. You might want to use it in the crossover seasons on the higher temperatures. So we'll take a look at that. Now, we want to look at kind of, you know, how technology's changed with heat pumps today. You know, we hear about our grandfather's heat pump, and you know, heat pumps had a bad name back in the 70s and 80s. It was an expensive way to heat your home. Okay, that's changed today. Okay, the heat pumps today do not heat when it's cold. We can get 0-degree days where our heat pumps heat at 100% of the efficiency of what they're supposed to do without any backup electric resistance heat. You do not need that anymore with the systems that we have. And so how does it work? We have a compressor, like I showed you guys earlier, inside the unit, okay, that speeds up when it gets colder. All right? The compressor gas gets real hot that's in there, and then it adds refrigerant to cool the compressor off. So we can heat at these low temperatures now with heat pumps with no backup electric heat. All right, so a conventional heat pump back in the day, you know, at 47 degrees, you could heat your homes with no problems with these, and these were efficient to heat your home with, okay? At 23 degrees, you used to see that the heat pump would start to lose capacity, and this is where the cost would start to come in, where you would have to use that. So now, at 17 degrees, we're still at 100% of the capacity with our heat pumps. And at 5, we're still 100%, a conventional one is 30, and at -13 degrees, we're still at 76, and this heat pump just will not heat at all. So let's take a look at some acronyms and what they stand for. You know, you see SEER rating. You hear a lot of that with air conditioning. You hear EER, HSFP, and COP. This is how the power companies look at how efficient an air conditioning system is. So the first thing they go and they look at is they look at the SEER rating. Okay, that's the cooling output during a typical cooling season for the energy input. And they base this on a number, okay? 14 SEER is the lowest SEER right now that has been mandated by the federal government that says, hey, if you're going to put in an air conditioning system in your home, it needs to be at least 14 SEER. The higher the number, the more efficient it is. We have systems that go up to 33 SEER. Okay, so the higher the number, the more efficient it is. So, you know, when you look at buying an air conditioning system, if it's a 14 SEER system, it is pretty much the bottom line equipment that most builders use in a home because that's what they need to use in a home. They have to meet that efficiency ratio, and they can't even, distributors can't even sell anything below that in the United States anymore. The EER is the same as the SEER, but it measures at a given out point, a given operating point, typically 95 degrees and 80 degrees Fahrenheit of return air coming into the units, okay? So this is more on the heating side of how we measure the EER ratio. Again, the higher the better, okay? The HSFP is a ratio of heating delivered versus the electric supply. So this is where we start to get into electric resistance, heat, and air conditioning of how we're gonna rate that. And then we got the coefficient of power, which is the electric energy supplied at a fixed state. Not to memorize them, but these are some terms that you see a lot when you're looking for air conditioning systems. And you know, when we start to look at these things, we look at boilers, we look at the average COP, we look at the direct heat, 0.82, furnaces, 0.98, resistance heat, 1.0, a standard heat pump at 1.86, and a multi-zone system at 3.7. So you can see our COP is much higher than anything else in here of how it operates. So it's the most efficient system on the market today for heating. Let's look at some of the decibels that the units put out, okay? When we look at common decibels, okay, a lawnmower running is about 90 decibels, a blow dryer is 80, a vacuum cleaner is 75, a human whisper is 30 decibels, all right? These are some of the sound decibels that are, this is an indoor unit right here, which you can see all across the walls over here. These are the sounds that they actually put out. So the lowest fan is 19 decibels. You can barely hear this unit running when it's on. A lot of people are like, I have a window unit in my bedroom now, I can't sleep. I can't sleep, the thing is going on, you hear the compressor on and off, very loud, blowing wind right at them when they're trying to sleep. Those aren't our systems. You know, the KJ unit right here, the KJ unit is a floor mount unit that sits down low that I'll get into in a minute. But when you look at some of these sound decibels from 30 to a human whisper to where these things run, they're super quiet when you're in the room and listening to them, okay? So we have a variety of different types of equipment today of how we do things. First off is your typical wall mount unit. These go up high, they mount in the space, they're a basic wall mount unit that goes into a home, all right? And then we have the floor mount unit, which is this one here. This mounts down low, all right? So this is more for, this can go behind a chair, replaces radiators, things like that that go in your home, all right? Then we have this unit here, which is the MLZ unit, that goes into the ceiling, okay, and it sits flush. It's this unit right here, right above, gentlemen, the white, little one over here, this one right here, that sits flush, and it blows out one way. It goes up into the ceiling, great for second floor bedrooms. They're 14 on center, it fits right between the bar joists. We come in, we cut a hole in the ceiling, and then that goes up and goes inside of the ceiling. This unit here is 2 feet by 2 feet, which is the unit right here, and that's a ceiling cassette. That goes up into the ceiling as well. So these are when you don't want to put something on the wall. That's great for a master bedroom. You have to have space above it in an attic. It's very hard to put on a first floor of a home where we have a second floor above it, because we have to run pipes and drains to that. So to get that in, that's a little bit difficult. This unit here is the SEZ model. This is this unit above my head. This goes in an attic or in a basement. It's usually designed for 2 bedrooms. So we take 2 bedrooms and make them one zone with one thermostat. So it's a very small unit for like, say like 2 bedrooms that are like maybe 12 by 12, something like that. And then we have the standard basic air conditioning system, which is this unit behind me, that we can use with just your straight ductwork, traditional systems like that, and then these are the controls that will go with them. I'll get into those in a minute. Now these right here all run with when we look at technology, when we look at the terms, I'm going to say, we have what's called single zone one-on-one systems. What do I mean by that? We have one condenser outside and one indoor unit inside. Wall mount, ceiling recess, floor mount, or ductwork. So this outdoor unit can only run one indoor unit inside. This is good for your maybe one unit in a home office, one unit in a sunroom, one unit in an addition, one bedroom, one family room. That's all you really want to do is one part of your home. You're putting an addition on your home or a finished basement, a hot spot or a cold spot in the home that maybe you need additional cooling or additional heating in that area, okay? So that's the single zone one-on-one system. Then we move into what's called our multi-port type systems, okay? This is when we get into our bigger condensing units that go outside, the unit I was telling you about outside, the condensing unit. That would be this unit behind you or the unit next to, up at the top there. All our single zones are on one side of the room, all our multi-zones are on the other side of the room, all right? So the system towards the back of the room has one condenser on it with two indoor units running on it with two different wall mount units on it, okay? One is a little bit squarer and one is a little bit more rounded. They're different style indoor units. The one to the right, the square, the boxier one, is the designer series unit, okay? That unit comes in white, black, and silver. It can come in 3 different colors. The one towards the food table is a GL style unit. That's a standard unit that's been around forever. Okay, so Chip, can you point to the GL up there? That's the GL, and the other one is the EF series. Designer and regular come in multi-port. You can do that unit there, that system there, up to 5 indoor units off 1 compressor outside. All right, so 1 unit outside, 5 units inside can go with that, okay? So that can come together and put that like that, all right? The next systems that we're going to get into are the multi-zone branch box style systems. This is where we can do up to 8 indoor units in the home, okay? And this is where we can mix and match many different style indoor units, as you can see. We've got cassettes, wall mounts, floor mounts, ducted units, and we add in this little box right here called the branch box. That's that silver box sitting on the wall right there with all those pipes coming to it, okay? This is what we get into when we get into the bigger systems. When we're coming in to do a whole home, we're going to end up probably putting a branch box in your home at some point. All right, that either goes into the attic, the garage. I've done apartment complexes with that where that's gone into the laundry room, in the ceiling of the laundry room, and we bring everything to it. The good thing with that is when you get into the branch box system, you're only running 2 pipes from the box to the outdoor unit, which is this right here. You're only running 2 pipes. All the rest of the pipes are inside the home, whether they're in the attic or they're in the basement or however we put that. So that's your branch box style system. Again, you can use multiple different styles of indoor units with this. This is the good part of the system. It's very complex. If you don't want to put all 5 units on this right now and you only wanted to put 4 or 3, you can do that, and you leave these 2 open ports over here for later on. You could come back and do another section in the home with that. So let's talk about some of the controls and how they operate, okay? The basic controls are your handheld remote controls, all right? They are basic handhelds. Jason, can you grab one out there and just hold that up for him? That's your basic handheld remote controller right there. It comes with every system. Every wall mount unit is going to come with that. That does heating, cooling, and there is a dry mode on every one of those handheld remote controls, okay? So the unit does dehumidify as well as heating and cooling, okay? So there is a dry mode on there, all right? The next control that we use is this control here. It's called the MHK1 thermostat. This is like a basic Honeywell thermostat that we use. I highly recommend, like we've done some dorms and stuff like that, where you don't want the handheld remote controls to get lost all the time. Apartment complexes, things like that, we're always putting in the MHK1 controller because the remote controls are always getting lost, broken, you know, you can't find them. The good thing about this too is this actually says heating and cooling on it. It says heating, cooling, where, let me flip back one slide. This doesn't. These standard remote controls, which is kind of crazy, is that these are the actual symbols. They don't say heating and cooling. So the snowflake is cold, the sun is heat, where you would think the sun might be air conditioning in the summertime. So a little bit of a confusion and a little small, very hard to read. This is much easier control to work with for what you're doing. We can put regular thermostats on them. If you wanted to use a Nest thermostat, a lot of people like Nest and things like that. Different controls, we have an adapter that we can put onto the unit, and it can absolutely be used with that control. Okay, so we can use regular controls with that. So if you wanted to put your own thermostat, you could do that. The next thing is the Kumu Cloud. Okay, it's a Kumu Cloud server. is what it is, and these are the devices. It's a little white device right here, okay? Is the red dot showing up? No. This little box right here, this little white box, it's actually right here. This little thing that's flashing right here. This goes into the unit, and we put that inside of the indoor unit, and this is what allows you to operate this from a smart device. All right, so it brings up everything on the smart device of what you're trying to do. So this is what it would actually look like. So this would be an actual unit right here. So that's in off mode right now, but if that was your phone, that's what you would be seeing on your phone. All right, I'm going to bring up the next slide on this. That goes to the server, and this is what you'd see on your smart device. All right, so this would be your home. It would show the different, if you had multiple zones in your home with different floors, this is how you would operate it from your phone. And then this would be the actual modes, turning it on, turning it off, turning the temperature. You can do programming from this too as well. So if you wanted to do all your programming on your phone, you could do all that too, or a smart device, okay? We do integrate with Alexa and Google Assistant, so the Google Cloud will integrate with that. If you want to have Alexa or Google do what that you want the units to do, they will do that, okay? So that's a pretty good feature that they brought on this year to make that happen. So now we're going to get into a thing called integrated controls. Integrated controls are when we take your existing boiler, if you have oil heat, or propane heat, or even if you have gas, if you have a gas boiler. We come in and we can zone out your whole home and integrate it with your existing boiler, okay? We put this white box in your home, it's called the Kumu Cloud Station, and we come in and we integrate that. That has an outdoor air temperature sensor. It goes outside and it measures the temperature outside the home, and it says, okay, above 30 degrees, I want the Mitsubishi system to run the zones in the house. Below 30 degrees, I want the boiler to come on. I want to turn those off. That's with a gas system. With oil, we can do it at 10 degrees. We can do it at 5 degrees. We can lock out the whole thing if we want. And we can run up to 4 circulator pumps in a home with that, or any 4 devices that we would want to do. And we come in and we group all of the floors together. So example, if you had the second floor of your home had 1 thermostat, okay? And you had 4 bedrooms, and we had 4 indoor units. We would make all 4 indoor units come on above a certain temperature or below a certain temperature, so they can integrate with them and turn on and off. This is where now Mass Save has gotten involved with these rebates, all right? And some of these rebates we're going to talk about are pretty substantial. If you might have oil heat or propane heat in your home, you might want to listen to some of the dollars because they're pretty substantial. So this is what we're talking about by what we're making it do with the temperatures. You know, we're putting different things on and off on different temperatures, okay? So I know I'm moving fast, but if you have any questions, we can do that afterwards. So let's take a look at the whole home solutions and see how they would work, okay? This is what typically happens to a home when we come into a home. You don't have to do the whole home if you just wanted to do areas in the home, but this is typically what we see a lot is, you know, we try to come into a home and understand where do you live in your home. Most people live in 3 to 4 rooms in their home. They live in the living room, kitchen, bedroom, and an office sometimes, kitchen. So we kind of see how you live in your home and then where we would want to strategically place equipment in the home. And you can have different temperatures throughout the home. You can turn units off, turn units on, and you can have different temperatures. Some people like it cold, some people like it hotter. So you can see we can come in and do, you know, different comfort in the home, different areas. So, you know, there's many configurations when we come in and we look at a home and we say, okay, you know, how do we want to do this home? So if this was your home, you know, we kind of look at this and we want to come in and, all right, if you wanted to do the whole home, we'd have to look at breaking it down into zones, all right? So, you know, flying back to the last slide, we're looking at the home going, okay, this is a zone, and then as we move forward, you can see the different colors in the zone. So, you know, this would maybe be one area with 1 unit, this bedroom, this area would be 1 unit, and then a family room. So that would be a 5 single zone system. Going back to that multi-port system we talked about, we'd put 5 indoor units in that home like that. Again, if you just wanted to do the bedroom, you could do just the bedroom. This here is if we got into 3 zones. Say we broke this home down into 3 zones, and then we looked at this here. This could be a 3-zone system with 1 multi-port with three indoors, 1 outdoor unit outside, and this might be two single zones outside. You know, it's kind of like when we come out and look, it's, you know, what solution is right for your home? What fits your needs? How do you live? How would you want to do your home? You know, if it's parts of how you would like to do it. So when we look at it now we've got to look at the installation process and how it kind of rolls and what gets done. So, you know, we see a lot of times this doesn't get done right the first time. There's a lot of different trades getting involved now in air conditioning because they really think this is super easy to do. They think it's just 2 pipes and 2 wires. And sometimes it's not. We have a lot of electricians now who are becoming HVAC experts. We have a lot of plumbers now who are becoming HVAC experts. And you know, sometimes it's done right, sometimes it isn't. But you know, when we look at this process, it's a 6-step process. You know, it's selecting the location of where we're going to put the equipment, installing the indoor units, installing the outdoor units, interconnecting the systems. This is where it starts to get a little tricky right here, is on the leak test and the charging. This is where sometimes guys really don't know what they're doing, and then the testing, the charging and the testing. When you're hooking up multi-port units with a lot of wires and a lot of boxes, if you start crossing those pipes or crossing those wires, it just turns into a complete nightmare of trying to do what you got to fix. So, you know, step 1 is hanging the indoor units in the home. How do they get hung in the home? We measure them. We have a whole training process of training our guys on how to do this. And, you know, indoor units get hung. There's holes. You can see there's a little metal plate in the back of here of how they go on. Step 3 is condensers get set outside. Step 4, the interconnect piping gets put together between the indoor and outdoors. And then step 5 is the evacuation, the testing, the charging, and then this is the testing, okay? Right now, with testing with Mass Save, with MS Check, Mass Save has got a program out there right now with MS Check that most contractors are certified to do, and you're doing a third-party verification to actually make sure that that is the right way that it should be installed. So Mass Save, to get the rebates, has to make sure that the system has been installed properly, charged properly, and most times they're doing a site check after, you know, coming out and doing a verification that the units were installed properly. So we've done a lot of training on that in the past 2 to 3 weeks. We've probably got about 15 guys trained on that. So, you know, why is it important to use the right contractor when you do things? I highly recommend, if you're looking at doing this in your home, look, get 3 prices. You know, but when you're looking at the 3 prices, what am I looking at? What am I just looking to get the best price of the job, or am I looking to, you know, what can they do? Are they doing the MS verification check, the contractor? Are they going to do my rebate paperwork for me? Is that all done? You know, are they going to be able to provide through Mass Save right now? If you are an Eversource customer or a National Grid customer, there are 0% loans for up to $25,000. For 7 years. That's all being offered through Mass Save right now. If you're not a municipal, as long as you don't buy your electricity from a municipal, like a Peabody Light or Reading Light or things like that, there are some very substantial loans out there, up to $25,000 at 0% for 7 years. There's a qualification process for it. It's not that difficult. If you're an Eversource customer, we're in the PATH program now that just started at the beginning of this year. That's a pilot program that's running for 2 years with Eversource, and we can do the heat loan paperwork for you. Okay, you have to go to the bank, but we can get the heat loan authorization, and the rebates that you would get from Mass Save, we can take off of the price of the job. Mass Save pays us the rebates, so you don't have to wait 8 to 10 to sometimes 6 months to get these rebates back from Mass Save. And I don't know if you've ever tried to go into a computer and put in a rebate for Mass Save, but sometimes it's not the easiest thing. A lot of these jobs now, they want certain clarifications to do things. So, you know, is the contractor going to do that for you? Can that get done? These are some of the things that you've got to look at, because if you're trying to get a rebate and then you're not even going to get it, you might want to take a quick look at that, you know? So, you know, I mean, we've seen some disasters out there, you know? I mean, these are live jobs, these are real jobs that we've gone back and fixed. And, you know, this is you know, sometimes what gets done on your home. I've seen it happen way more than one time, okay? And that's not a cheap job. You know, this is, if you're looking for contractors, look, you don't want this. Look at the reviews. Highly look at the reviews, all right? Look at the reviews of the contractor. Look at the Better Business Bureau reviews. I'll tell you why. Better Business Bureau reviews have to be verified, all right? They've got to be verified through the BBB. And if there are complaints that you can visually see as a homeowner. What were the complaints and how did the contractor rectify the complaints, okay? So, you know, you see, you know, the Angie's List reviews, you see the Yelp reviews, you see things like that. The BBB is a moderator between the contractor and us. Look at the BBB reviews. I'm telling you, those are the best ones to go look at. This is how we do our work. This concrete pads get poured or get set. Everything goes on a stand, okay? The reason why outdoor units go on a stand is for the winter time, for the snow, all right? But I mean, that's how a job should look, okay? These are some homes here. You can actually see, you know, people are like, okay, what's gonna happen on the outside of my home? You can actually see a little white line right here. See right here, next to the electrical? That's where we ran our pipes and wires for our indoor unit. All right, so when you see that little piece of brown plastic coming down, the white plastic coming down, and the gray plastic coming down, that's where the interconnect pipes come from the indoor unit to the outdoor unit. There's two pipes, a wire, a drain, and electrical in there. And we try, there's another one right here on this home. You can see it right here, white on white. And this one here, you can see the unit was mounted here, and we kind of followed here, came down. There's actually an outdoor unit sitting right here. Okay, so, you know, these are the things you want to look at as a homeowner is, hey, show me some pictures of some jobs. Show me how you did things, how you got this done, how did it come together. You can actually see right here too, this is an ivory piece of plastic that matched the home, and then the white, we put the white right on the corner to match the corner trim too. So it's being very cautious of how we're going to come out and do your home, okay? We don't want to do this. That's not what we want. We don't want that. I'm going to show you some case studies, some things we've done. We're up in Newburyport. Okay, this cape here, this converted from propane to ductless for year-round comfort. This was a 5-zone system. The cost to install this was about $18,000. The Mass Save rebate was $500 on this, which was a 0% loan for 7 years. In an annual heating and cooling savings, they had 5 window units and propane heaters, $2,500 a year that they're saving in that home today. And these are actual studies we've done with people. This is a 2-zone Mitsubishi ductless system that we did with ductwork. Okay, this was an oil burner that they took out of the home, and we put two units like this into the home to heat the home. Complete heating system and cooling system. Mass Save rebate was $1,000 on this, 0% interest loan, again for 7 years, and an annual savings of $4,000 from oil and electricity. So it's, you know, got some payback in that. Some of the rebates that are going on right now, okay? These are the rebates from Mass Save. All of the rebates, I don't know how rebate conscious you are or anything of what happens, but if anyone was looking at doing this last year, there was a group called the Mass CEC, the Clean Air Energy Council, which has been kind of taken out this year. They're not involved in the rebates anymore. Everything is switched over to Mass Save and Clear results. Some of the rebates have changed, so an existing type air conditioning system with ductwork on it, and again, these are these C ratings and these EER ratings we were talking about earlier when we look at these numbers. Remember we were saying 14 was the lowest, 16 has to meet 16, it's got to meet an EER of 13. That's $50 per ton, okay? What do we mean by ton? When we say 12,000 BTUs, a 12,000 BTU unit is 1 ton. So that's with ductwork, that's $50 per ton. So if you have a 3-ton system, that's $150 of rebate. Not so good. That's not a big rebate at all. And this is any existing fuel. So existing fuel type, what we mean is how are you using to heat your home? You're using electricity, gas, oil, whatever you're using. Now we go into here. If we put ductwork in your home and a wall mount unit, so say we do something with ductwork and something with a wall mount, that goes up to $350 per ton. So with a 3-ton system, that's going to be like $1,050, all right? Now if we start displacing the propane or the oil, okay, we start to put in a system where we have oil or propane, and we're putting in an air source heat pump, and we're putting in ducted units and mixed units, wall mount units and ducted units. That gets up to $1,000 per ton. So now we're looking at $3,000 rebates. Okay, now we're going, okay, what's happening here? Okay, then we have just the regular wall mount units. Okay, those are $150 per ton. This is now where it gets a little more interesting. If you're displacing electric heat, if you've got electric heat in an area of your home or in the whole home and you're heating with electricity, okay, with the difference of, they take 3 months and they look at the difference of 900 kilowatts. If your electric bill shows a 900 kilowatt difference from the winter to the summer, you're eligible for $1,000 per ton. So if you're heating a home with electricity in an area of your home and you've got a great electric bill greater than 900 kWs, and we can look at that bill and see, okay, what are we doing? Now we're falling into the $1,000 per ton range, okay? Now let's talk about if you have oil or propane in your house and you're going to integrate it with your existing boiler, okay? Now we're talking that we would come in and we would put this control, like I was talking to you about earlier, to turn your boiler off at a certain temperature and put the air source heat pumps on. Now we're into $1,600 per ton. All right, so I've seen, we just did a rebate the other day for I think it was 10 zones in the house, the rebate was $11,000. So these are pretty substantial rebates of what we're seeing right now if you've got oil in that in your home. That's why I wanted to talk about heating in the beginning versus just cooling, because you have to be aware of some of these rebates of what's happening, okay? And then there's what's called the integrated controls, okay, where these are $500 up to $1,500, okay, per zone. So this is when we start to come in. If you didn't want to put in integrated controls, but you just wanted to put in like N.E.T. thermostats with those adapters I showed you earlier, there are rebates for that as well. So when we start looking at these different controls and how we put things together, they work very, very well. All right. So what is an integrated control? Again, they are the Kumu Cloud Station that we talked about. That was at this white box right here. The little wireless interface that I showed you earlier, those would go into the indoor units. They need to be operated from a smartphone. And then there's the outdoor air temperature sensor that I talked to you guys about earlier that would need to go outside. These are the other controls that I just talked to you about. If you wanted to stage them with the thermostats, you would have to do the thermostat interface. There's a little transformer we need to put in, and then a 2-stage thermostat. So that's how that would all go together as far as putting the integrated controls on there. So that's pretty much my presentation. I got through it in 45 minutes. I know it was fast. Questions?
You talked a lot about the housing. What if you have a condo?
Condo? And what are you trying to do?
It's a heat pump, air conditioned pump.
Heat pump?
Try to use your system within the...
We do have the one-on-one system like we talked about, where we take the existing heat pump out, put in this style heat pump, reuse the ductwork, put in a high efficiency outdoor unit, and no more backup electric heat. Don't put in the backup electric heat.
Whatever zones you wanted, like bedroom versus...
You could do bedrooms, you could do zone out, you could do a mixed system, you could put ductwork and wall mount units.
How does your potential rebate get measured if you have base water heat?
It's electric?
Yes.
It gets measured from your electric bill. We have to look at your electric bill and see the 900 kilowatt difference, which if your home is being heated by electricity, you're going to see X amount of kilowatts. You know, they show the little bars on your electric bill. You're going to see that in, December, January, February. Then we're going to look at, May, June, July and see that there's no electric use. That measures the 900 and puts you into the qualification.
So do I need to have my electric bills for all those months?
No, one bill will show those months. One bill shows a year's usage. Or if we have your electric bill, we can get with Eversource, or is it Eversource or National Grid?
National Grid.
National Grid, you can get that online to see what those numbers are. So.
Sorry, I came in late.
That's all right, don't worry about it.
But I got the gist of this.
Okay.
So one on one, are these over here?
These are one condenser, one indoor unit. Mm-hmm.
Okay.
Yep.
So in my mind, okay, this is what I'm thinking. have a very inefficient 1932 brick Tudor. So we've got 8 rooms, 3 bathrooms, of which we only stay in 3 rooms for the most part.
Yep.
So I'm thinking, why would you want to convert the whole house?
No, doesn't have to be done.
Yeah, so unfortunately I'm married to an architect and he's very fussy
Very particular.
and he's not here.
That's okay.
What he's worried about is the outside of the house. So have you done brick homes before? And how does the outside look?
Brick would usually be done in brown.
That's
Would-
good.
Would usually
Yeah.
be always done in brown,
Because the trim is brown.
and it
so-
usually stays to the corners.
Okay.
Usually,
So-
you got it. It's definitely a design issue to go out and look at. Sometimes the pipes don't need to go outside.
Oh, interesting.
Sometimes
So
the
you
pipes.
would
You have a
love
full
that.
basement.
Yeah,
You have a full basement.
yes.
Is it unfinished?
Yes.
You could bring pipes down through the closets, put them in the corners of the closets, and then bring them outside.
Yeah, you
Yeah.
need somebody to talk to.
You need, yeah, that's a design issue, but yeah, no, if it's, I mean, I've literally had people open up walls in the house, you know, put a hole at the bottom of the wall, if we're doing an interior wall, and we run the pipes right down through the wall in the house and bring it into the basement, so nothing goes outside. You know, we've done buildings, we've done new construction buildings where there's no pipes outside. The pipes just run in the walls and go right
So
outside.
that outside unit we're looking at, how does that work inside? I guess I'm not really,
How does the outside unit?
yeah, you know, one of these things.
That would go sit outside the home.
Okay.
That sits outside the home, this would sit inside the home.
Okay, so how do you get to this though? I mean, you'd have to break through that brick wall to get.
You'd have to drill through something to get those pipes outside, yeah.
Okay.
Yeah, and we
Not a
core
big
drill
deal.
that, you know,
Right.
drills that make cord
Holes.
holes and things like that.
Through brick.
Through
right?
brick,
Okay,
yes.
that's what I wanted.
Yeah.
So 3 rooms would be okay to do.
Yeah,
Yeah.
we've done, we go into a lot of homes, that's why I said to you, think about where you live in your home. Where do I live in my home? Where do I want to be comfortable in my home? You know, a lot of times it's master bedroom, kitchen, living room, dining room, office, things like that. Sometimes people don't do their whole home. You know, sometimes people do, sometimes people don't. It depends
But if
on,
you-
depends on your lifestyle.
If you do 3 rooms, could you at some point expand to?
Yes, yes, you could buy a 5-zone outdoor condenser and you have 2 ports additional to add more to it at a later date and time, absolutely.
What would be the difference in price for like a 5-port versus a 2-port?
That really all depends on when we come out with a 5-port to a 2-port. The outdoor unit, just the outdoor unit, probably $1,500 maybe, somewhere in that range, you know? I mean, it really drops the price from a 5-port, 5-head system to a 2-port system. That's like thousands of dollars now we're talking about.
External noise ratings for, condo associations and things like that, for the compressor outside. Do you have a feel for what it is for, let's say?
40 decibels. Let's turn one on. I'll let you hear one. This again. This would be what you'd see from the smart device. Can you flick on that GL right there, dude? I just turned that on from the smartphone right now, so that you can see that blade's opening up on that unit. That's coming on now. That will ramp on. Designer Series has a little bit different vanes, how it opens up, how the air comes out of it. So that was being operated by the handheld, that was being operated by the smartphone. Can be operated by the thermostat too as well.
So my question wasn't for internal noise, it was for external.
You're gonna hear that, you're gonna hear that come on in a minute.
Those are also in the same range, 48 to 50 decibels.
That's
How
on.
many?
50 at a max.
That's on right now.
That's full ramped out.
You hear that?
Fully ramped?
Come over and listen. That's ramping up right now.
You can't tell it's on.
This is quieter than the indoor unit. And that unit's on completely high right now.
Feel it.
I'll turn that down.
Just do it.
See, that's on.
Yeah.
You hear it?
Yeah, no, that's impressive.
Yeah. I mean, I just turned that down right now. I mean, this whole system is running right now. This is on and running. Right now, it's ramping up.
Do that.
That's all on and running. I mean, it's super, super quiet as far as what you hear. You know, this unit's obviously a little bit louder. It's got 2 fans in it when it comes on, because this is running multiple units, and this will speed up and slow down on what you need. When this is all within 1 degree of room temperature, it just kind of sits there and just yeah, I mean, listen, I can't even, that's on and running from a sound standpoint.
I'm old, I can't hear it.
Yeah. I mean,
Thank you.
you're welcome.
And you can have those units up there instead of wall units?
I'm sorry, what?
You can have those units,
Yeah, this goes up in the ceiling here.
so if you have access to the attic, you can put those up
Absolutely, yep.
instead of the wall
Yeah.
unit in the room?
We've got 5 guys back here, if anyone wants to see, touch, and feel. I know some people might want to leave. If you want to leave, that's fine. I can turn on anything you want. We can hear it, you can listen to it. We've got single zones over here. We've got all kinds of different controls we can let you listen to and go together, so, all right?
And what about security on the Wi-Fi?
Security?
On the Wi-Fi stuff? Is it password?
It is password protected, yes. Yes, it is password protected. You have to get into the, yeah. This all has a password to get into it. I mean, I don't have it on a password now, but you can see that it does show, it's showing 5 units on here. So this is showing this unit, and I have multiple different condensers running off of that. You don't need to have one smartphone to do all, it can do all of the different units. I can turn on that one behind your head over there. I'll put that one on now. So that one, so now I'm turning on that one over here. From there. That'll come on in a second. Set it to signal to it. Huh? No, it's coming on. Takes a little bit. I know. That unit there, this unit here, the EF unit, this is a little bit different. This is very, very smart technology. All right, you can see this unit. See how I just walked over here and that eye looked at me? This eye is looking around the room. It's looking to see who's over here, what's the temperature over here, and then it's got electronic. This is a two fan system in here, so you'll see these vanes are split, so you can point air that way, point air this way, and then there's electronic vanes inside. Like, see now it's looking over here. It's looking for hot spots and cold spots in the room, and saying where do I want to direct the air to. All right, so this is always communicating to this, saying, hey, what do I need to do? You know, and you can hear that. That's on. I mean, that's on and running right now. And I mean, it's got minimal vibration of what you're doing. So this unit, very smart. That unit's a little bit bigger, as you can see, than this unit here. That's about 40 inches. This is about 30 inches roughly. This is when you start to get into the 24,000 BTU, the 30,000 BTU, the 36,000 BTU. The bigger the BTUs, the bigger the indoor unit gets, the bigger the outdoor unit gets. This is just a typical, this is a 15,000 BTU unit. The 6,000 up to the 18,000 can stay in this size chassis right here, in this indoor unit for size-wise, all right? And then obviously the outdoor unit would get, the outdoor unit pretty much stays the same size up to about 18,000, then it starts to get bigger.
What kind of square footage with 18,000?
18,000, figure this for a good rule of thumb, for every 400 square feet of space you have is roughly about 12,000 BTUs. All right? So like a 200 square foot bedroom is like a 6,000 BTU unit. You know what I mean? So when we start to get into the bigger homes, you know, the bigger the units get. And we go anywhere from 6,000 up to 60,000 on the residential series. So we have that unit can go up to 60,000 BTUs, and you can run 8 units off of that into the 5-ton range. So then you're up, when we say 5 tons, 60,000, it's 12,000 times 5 is 60. So that's a 60,000 BTU system. So, and you can see there's a lot of different style. Like I said, floor mount units over here, that mounts down low. That unit up high right here, you can put ductwork on. That unit can go into a ceiling. That unit can go into a ceiling. And then we have the wall mount units over there. Again, that one in the middle, that's a little bit boxier than the others, Comes in white, silver, and black. All right? That's a designer series unit.
Have you previously talked about the warranty?
The warranty on everything is 1 year parts and labor, and then an additional 11 years on all the parts. You can buy a 12-year parts and labor warranty through us too. You can get a complete 12-year parts and labor, but it's all 12 years on all of the parts that we purchase through that now. 12 years on the compressor, 12 years on the coils, parts, things like that. So
So what's the average life if the warranty?
average life expectancy of a unit is 20 years, 20 to 25 years.
So
I've got systems out there that are 20 years.
After, let's say, 12 years, right? Do people buy extended warranties or they just?
12 is the max. 12 is the max on the
wait it out
warranty. Yes.
Between the
Uh-huh.
12 to the
Yeah.
end of life.
Yep. 12 is the end of it. So. Any other questions?
Was that for the outside unit expectancy? Or all the units inside?
I'm sorry, what?
The life expectancy is outside?
Everything.
Everything.
Everything, the whole package, yeah. And again, it all depends on how, hang on a second. It all depends on how well you maintain it too. Like I've had units, seriously, we've taken them out in 10 years because no maintenance has been done to them at all. What I mean by maintenance is, coming out once a year, washing, cleaning. It's just like your car, I mean, would you drive your car for 5 years and not change the oil in it? We have to come in and we wash and clean. I mean, when you look inside these units, okay, filtration is all right here. So this is the actual filtration. This is the filters that go in. There's an anti-enzyme filter in here, but this gets washed and cleaned. I mean, once this can only hold so much dirt, and then the dirt starts coming through the other side of it, and then this starts getting all dirty and all plugged up. Then the drains start getting all plugged up, and then the mold starts building up and everything else. So I mean, you want to wash and clean, have this professionally cleaned once a year. We have special machines we actually just purchased to do this now. We were doing a lot of them by hand. Now we have these little tiny power washers. They're about this big. We can come in and clean that unit in about 5 minutes for you.
Do you
Has
put
a
in
bag that goes underneath it.
new filters or you clean the existing?
Clean those filters, clean them. The blue one gets changed, the little blue one gets replaced,
Yeah,
and the other dark blue one gets washed.
but when you think about it, people buy new cars, 35,000, they don't last 12 years. I mean, people keep buying new cars.
Yeah, no, I mean, but yeah, this is a permanent fixture in your home that you're leaving.
And what's roughly the annual maintenance cost?
Annual maintenance for something like one indoor, one outdoor is about $129 to come in and do it. We're there, and we're not just washing the indoor, we're washing the outdoor unit too, because there is a coil. This fan blows out, but when it's blowing out, it's sucking in. So behind the back of here is a coil, like I showed in that picture earlier. So that coil gets pollen in it, gets dirty, gets leaves in it. I mean, you do need annual maintenance. I mean, if it's something you want to just hose off by yourself and wash it down and wash off the indoor unit, if you do it, look, the more periodically you do it, the less dirty it gets. It's like washing your car. If you never wash it, it just gets completely dirty. If you wash it all the time, it stays clean. So it stops the mold from building up in there and everything. But again, you can hear that unit at the back now is pretty much run up to full speed, and we really can't even hear it running in the room. So, any other questions?
You've got the units about a foot off the ground or so, and you were talking about that being for snow.
Yep.
We got a few winters, snow's been a
You
lot.
can buy
more
it.
than a foot off the
You can
ground.
buy it in 2 feet if you want.
Do you need to clear snow out from around it in winter?
If you're going to be heating 100% of the time with it, absolutely, yeah. But you got to remember, if this is running while it is snowing, the fan is blowing, so it does tend to blow snow and things away from it. But yeah, it would need to be cleared. You can get this stand in a 2-foot stand too.
Yeah.
We found the 1 foot works pretty well. Works pretty well. It doesn't. And we look at snow drifting when we come out to your home of kind of where it would be and how you would put it, everyone kind of knows at home where drifts do come when when nor'easter comes and how the wind's going to blow around there. So, but yeah, we definitely need to. Yeah, I mean you can't. It's like a vent pipe in your house with a gas furnace, and you've got a drift there. You don't want to drift in front of your gas furnace vent, so you got to clear that out. There's books here on your tables. Please feel free to take these, okay? This is an ebook that I wrote just on cooling. It explains zoning. It talks about zoning and water. There's a good illustration in here of your home that we felt was pretty good. for turning light switches on and off, and how we would zone out your home. So there's some good literature in here on this here, and then in this here, this is all of the different models, again, with the zoning and everything. Feel free to take this with you. This explains all of the different indoor units and the multi-units that we went through today. There is a foldout in here. Where is it? Right here. When you start looking at these different units in here, you'll see these different symbols. All right, and this tells what it will work with. It'll show which system it will work with. Any questions with that, please feel free to call us. Everything on the back is on here. All our phone numbers are on here. Our website's on here. Everything, if you want to go out and look at any of that stuff from there. So, all right. Yeah, if you don't mind, if you could just get your name, additional information from you guys, if we could, that would be great. We're not going to call you and hound you. We'll just put you into our system and periodically email you some information that you might want. So, all right. Thank you, everyone, for coming. Enjoyed the day. I know it's sunny out and everyone wants to get out of here. So I'm amazed at how many people came. Thank you.